Alright, one more problem. Find the volume of the solid formed when the shaded region is rotated around the y-axis. Okay, so in this case, we're taking this shape and we're going to end up rotating around like this. Ooh, that's not too good. Let me try that again. So we're rotating around like this. Alright, and the shape is going to again, have a little sort of dimple in the middle. It's going to not quite go all the way through, but it's pretty much going to go all the way to the bottom. There won't be a hole, but there won't be any space either. Okay, so here we go. The inside of this function, the inside of this shape, will be defined by this sine function. And, oh, do I have enough room? I don't have enough room up there. Let me draw it down here so you can get a good picture of it. Alright, so this shape, the inside of it will look like this. On that side. And on that side, you can see this is the hole in the shape. You can see that it's coming down to a point there. And it will rotate around, so it's going to have this little weird flower lily sort of thing going on. And let me shade this in a little bit for us. So this is going to be pretty, okay, so that's going to be like that. This one's going to be like this. Okay. Nothing too surprising here. And then we have this sort of, okay. That's the inside of the shape. Looks like a really dumb upside down hat. Okay. The outside of this shape is going to be defined by this parabola right here. So that's going to be defined like this. And this, you can see already, there's going to, ooh, that's not good. You can see already that there's going to be some space in between here, and that's where the actual object, the solid, is. Oh, I'm not doing so well. There we go. Okay. And this is going to be the front lip of that, and this shape will be sort of like this. Let's shade this all in. Okay. Alright, so that is the overall shape of it. Kind of like a really weird bowl with sort of indentation going all the way down here. Okay, so here's what happens. Instead of trying to cut it like this, like we did last time, because I'd have to find, I would have to then find, let me pick a good color, this distance, and I'd have a square root here, and I have an arc sign here, and that's not good. So, instead of trying to do that, I'd rather have to find these lengths here, okay? And that is going to be the height of a shell. And we can see this height. It goes from up top here on the blue curve down to here on the green curve. And that's just going to end up being equal to the top curve to sine of pi over 4x. That looks like a 9. Pi over 4x minus this curve, 1/2 x squared. And in addition, another nice thing is this radius right here which will be changing, is just x. So we're going to start really close here and get these heights and then spread it out. And when I put this in here, what actually happens is this will rotate around the object and give me, okay, let's see, so it'll look like this, and I'll get a shape like this. And so I'll actually get this sort of shape, this cylindrical shell. Okay, so we get these cylinders out of there, and so we need to find the surface area of this cylinder. So this, or the lateral area. So the area we know in terms of r and h will be the circumference, 2 pi r, multiplied by the height, h. And we figured out that this r is equal to x, because you see we go here, and that radius is the distance from the y-axis. So the area as a function of x will be 2 pi x multiplied by this height function, which is big and ugly, but this height is determined by the distance, vertical distance, between the inside and the outside. We put the top one on top first because it's positive and we have positive heights. So multiplied by 2 sine of pi over 4 x minus 1/2 x squared. And that's my area function. And if we recall, as with all of these, my volume will be the integral of this. So the integral, I can see that this right here is 0. It looks like I have the point 2, 2. If I put in 2, I get 2 for both of them. So it is 0 to 2. I'm not showing that work here because it'd take more time, but you would set these equal to each other and solve for that. So integral from 0 to 2 of the area function, which is, so this is volume, is equal to 2 pi x multiplied by 2 sine of pi over 4 x minus 1/2 x squared dx. And let's bring the 2 pi out in front like we always have been. So that's going to equal 2 pi multiplied by the integral from 0 to 2 of, to 2 of x multiplied by 2 sine of pi over 4 x minus 1/2 x squared dx. And now we can go put that into the calculator. So bring out the calculator, turn it on, make sure it's running. Okay, math, 9, not yet, sorry, 2 pi. Okay, 2 pi multiplied by math, fn int, of x times 2 sine of pi divided by 4 times x, close that off, minus 1/2 times x squared, close that off. Okay, make sure that's right. 2 sine of pi over 4x minus 1/2 x squared, closing off that parentheses. Okay, comma, x, as x goes from 0 to 2, and I should get 7.805. Let me make sure that I had everything in there. The radius, the top function, the bottom function. Okay, So 7.805, and that is going to be approximately my answer. So it's approximately equal to 7.805. Final answer.